The smoke stopped rising from Alexander Kowalski's chimney on a frozen January morning in 1843. But his cabin stayed warm for 16 days straight, while his neighbors burned through cords of wood just to survive each night. What they had mocked as a madman's project, a stone-lined furnace buried 4 feet beneath his cabin floor, would transform frontier heating across the Northern Territories and save dozens of lives over the next 2 decades. Before we begin, let us know where you're watching from, and if stories like this move you, hit that subscribe button, because tomorrow's story is even more impossible than this one. The temperature dropped to 20 below zero on January 9, 1842. Alexander Kowalski woke to find frost coating the inside walls of the cabin despite the fire that had burned through the night. He added more wood to the stone fireplace, watching flames climb the chimney, feeling their heat for the brief moments before it vanished upward into the Wyoming winter. Across the small cabin, his partner Joseph Novak coughed, a wet rattling sound that had started 3 days earlier and worsened each night. They had been trapping beaver along the Wind River since October, working the high country tributaries where few other trappers ventured. The isolation meant better yields, but also meant no help if trouble arrived. The cold snap that descended in early January was trouble of the worst kind. Temperatures that made steel brittle and turned breath to ice crystals before it left your mouth. The kind of cold that killed. Alexander fed the fire constantly, every 2 hours through the day, every 3 hours through the night. The fireplace consumed wood at a rate that alarmed him. They had cut and stacked 4 cords in the fall, estimating it would last through March. After 5 days of brutal cold, they had burned through half of 1 cord. The mathematics were simple and terrifying. If the cold continued, they would run out of wood by late February, with a full month of winter remaining. Joseph's condition deteriorated despite the fire. He had gotten wet checking trap lines 2 days before the cold arrived, and his clothes had frozen before he could return to the cabin. The hypothermia set in gradually. First the shivering, then the confusion, then the dangerous drowsiness. Alexander piled every blanket they owned onto Joseph's bunk, kept the fire roaring, heated stones and placed them around Joseph's body. Nothing worked. On the 6th night, Joseph died, not from any dramatic cause, just from cold that the cabin could not keep out, despite the fire burning 6 feet away. Alexander sat beside the body until morning, feeding wood into the fireplace mechanically, watching heat climb the chimney and disappear. He understood something in those dark hours that would obsess him for months. The cabin offered almost no protection. The fireplace was not a heating system. It was a wood consumption system that produced heat as a byproduct, most of which escaped unused up the chimney stack. He buried Joseph the next day on a hillside above the creek. The ground was frozen 18 inches down, and digging took most of the day. That night, alone in the cabin, Alexander burned wood and thought about heat. Not fire, but heat itself. Where it went, how it moved, why frontier cabins stayed cold despite constant fires. By morning, a memory from his childhood in Poland had returned with absolute clarity, and with it, an idea that everyone would call madness. Alexander spent 3 more weeks in the cabin, completing the trapping season alone. Every night he burned wood and thought about his grandfather's farmhouse outside Krakow. The house had a massive clay stove called a PS that dominated one wall of the main room. His grandfather fired it once each morning, loading it with wood that burned hot and fast. By noon, the fire was out, but the house stayed warm through the entire day and into the night. The clay absorbed heat and released it slowly for 18 to 20 hours. American frontier cabins had abandoned this principle entirely. Speed was valued over efficiency. A trapper could build a stone fireplace in 2 days. The fireplace produced immediate heat. But it was inefficient in ways that most men never considered. Hot air rose directly up the chimney, carrying most of the fire's energy with it. The stones of the fireplace heated, but they faced the fire, not the room. Their stored heat radiated mostly into the firebox itself, not into the living space. Alexander examined his fireplace with new attention. He held his hand near the stones. They were warm, even hot near the firebox, but that heat was wasted, trapped behind the fire, absorbed by stones that faced the wrong direction. Meanwhile, the room stayed cold except in the immediate vicinity of the open flames. This was accepted as normal. This was how everyone built. This was killing people. The mathematics of heat storage began forming in his mind. His grandfather's piece weighed perhaps 3,000 pounds of clay. It absorbed heat from a hot, fast fire, then released that heat slowly over many hours. The thermal mass was the key. Not the fire itself, but the material that stored the fire's energy and metered it out gradually. Frontier fireplaces had thermal mass, but it was oriented wrong and inadequately sized. What if the entire heating system was reversed? What if the firebox was surrounded by thermal mass on all sides? What if that thermal mass was positioned not behind the fire, but beneath the living space, so that stored heat radiated upward into the room instead of into the firebox? What if the floor itself became the radiating surface? The idea seemed obvious once he considered it. Bury the firebox, surround it with stone. Let the floor absorb and distribute heat. Fire it intensely but infrequently. Let thermal mass do the work that constant fire tending currently required. The more he thought about it, the more certain he became. This was not speculation. This was physics his grandfather had understood without formal education. In March, Alexander packed his furs and rode to the trading post at South Pass. He sold his winter's take for a decent profit. Other trappers celebrated the end of trapping season with whiskey and stories. Alexander purchased tools, a heavy pickaxe, a long-handled spade, 2 iron pry bars, a stone hammer, canvas for hauling. He told no one what he was planning. When Eleazar Godwin asked about the tools, Alexander said only that he was making improvements to his cabin. Improvements, Eleazar would later say, was not the word anyone would use for what came next. Alexander returned to his cabin in late March. Snow still covered the high country, but the brutal cold had broken. He spent the first week clearing his trapping equipment, processing the last of his stored furs, and preparing for construction. Most trappers would have left the mountains by now, heading to settlements for summer work, or returning to trap new territories in the fall. Alexander stayed. The heating system he envisioned would require months of work, and he wanted it finished before the next winter arrived. He began by sketching designs on sheets of bark using charcoal from his fire. The concept was straightforward, but represented a complete inversion of standard construction. Dig a chamber beneath the cabin floor, line it with stone to create thermal mass. Make the chamber deep enough to hold significant heat, but accessible enough to load with wood. Create a narrow opening at floor level that would concentrate combustion and create intense heat. Engineer the floor itself to allow heat radiation while maintaining structural integrity and safety. The challenges became apparent as he sketched. How deep should the chamber be? Too shallow, and the thermal mass would be insufficient. Too deep and loading wood would become difficult. He settled on 4 feet, a depth that would provide substantial stone volume while remaining accessible. How wide should the firebox opening be? Traditional fireplaces had openings 2 to 3 feet wide. Alexander decided on 18 inches. The narrow opening would create a furnace effect, concentrating heat and creating powerful updraft that would drive complete combustion. In early April, Eleazar Godwin stopped at the cabin while passing through the territory. He found Alexander surrounded by bark sketches, planning measurements, calculating stone requirements. Eleazar examined the drawings with growing disbelief. "You're going to dig up your cabin floor?" he asked. "You're going to put your firebox underground?" Alexander explained the principle of thermal mass, the inefficiency of standard fireplaces, the physics of heat storage. Eleazar listened with the expression of a man humoring someone who had lost touch with reality. "Heat rises," Eleazar said slowly, as if explaining something to a child. "You're burying your heat source below the floor. That's backwards, and you'll suffocate any fire in a hole that deep and narrow. This is madness, Kowalski. Your partner's death affected you more than you know." He left, shaking his head. Within 2 weeks, half the trappers in the territory had heard about the Polish trapper who was digging up his cabin floor to build a fire pit. Rufus Crenshaw, a trader who traveled the mountain settlements, made it a story he told at every stop. Man lost his partner to the cold, and now he's lost his mind. Thinks he can heat a cabin from underneath like some kind of baking oven. Alexander heard the stories when trappers stopped by to see the madness for themselves. He stopped trying to explain. Understanding would come later, or it would not come at all. Either way, the work needed to begin. He had until October to finish. The next winter would prove who understood heat and who simply built fires. The first week of May, Alexander began removing floor planks from the center of his cabin. He had built the structure 2 years earlier using standard methods: logs notched at corners, planks hewn from pine trees, a dirt floor beneath the wood. The planks came up easily, revealing packed earth underneath. He marked a rectangle 4 feet by 6 feet in the dirt. This would be the chamber. He picked up the heavy pickaxe and started digging. The ground was still partially frozen 2 inches down. The pickaxe rang against frozen soil and hidden rocks. Each swing jarred his shoulders. Each foot of depth required an hour of work. He loosened soil with the pickaxe, scooped it into a canvas bag with the spade, hauled the bag outside, dumped it, and returned to dig more. The process was brutally repetitive. By the end of the first day, he had excavated 6 inches of depth across the marked rectangle. Eleazar returned on the 3rd day with 2 other trappers. They stood at the cabin door watching Alexander work in the hole, now 18 inches deep. "Still digging your grave?" Eleazar called out. The other trappers laughed. One of them, a man named Cyrus, shook his head. "This is what happens when a man winters alone, starts making no sense." They did not offer to help. They watched for a few minutes with the fascination people reserve for incomprehensible behavior, then left. Alexander continued digging, 2 feet down, 3 feet. The chamber took shape slowly. The walls were rough, angled inward slightly for stability. Rocks embedded in the soil had to be pried out with iron bars. Some were too large to lift alone. He rigged a simple pulley system using rope and a roof beam to haul the largest stones out of the deepening pit. After 3 weeks of work, he reached 4 feet of depth. The chamber was complete from an excavation standpoint, but the hard work was just beginning. Rufus Crenshaw arrived in late May with a small group of traders heading east. He brought them to Alexander's cabin specifically to show them the project. "Look at this," Rufus announced, gesturing at the pit in the cabin floor. "Man thinks he's going to heat his cabin by burning fires underground. Probably read it in some book." The traders peered into the hole. One asked Alexander how he intended to load wood into something that deep. Another pointed out that smoke would fill the cabin with no proper chimney. A third suggested, not unkindly, that Alexander might benefit from spending time in a settlement around other people. Alexander climbed out of the chamber and faced them. "The smoke will vent through the existing chimney," he said quietly. "The depth creates draft. The narrow opening creates heat. The stone will store that heat for days." Rufus grinned. "Stone doesn't store heat for days, friend. It cools down same as anything else. You've wasted a month digging a hole you'll have to fill back in come fall." The traders nodded agreement. Alexander said nothing more. He returned to the chamber and began smoothing the walls with his spade. The visitors left, already forming the story they would tell at the next settlement. June arrived with warmth that made working inside the cabin almost unbearable. Alexander spent the first week of the month searching for stones, not just any rocks, but specific types that would serve the purpose he required. He walked the creek beds within 2 miles of his cabin, examining stones with the care of a jeweler selecting gems. Size mattered, shape mattered, but most importantly, the type of stone mattered in ways that most men never considered. He built a test fire outside the cabin and placed different stones around it. Some cracked within an hour as thermal expansion split them along hidden flaws. Others heated quickly, but cooled just as fast, retaining almost no warmth once removed from the fire. River stones with high quartz content sometimes exploded from rapid heating, sending fragments across the test area. Alexander made notes on bark sheets, categorizing which stones failed and which succeeded. The winners were dense river rocks worn smooth by decades of water flow and granite fragments from a rock slide he found half a mile upstream. These stones heated slowly but retained that heat for hours after being pulled from the fire. He held them in gloved hands, feeling warmth radiate steadily rather than flash hot and fade. These were the stones that would line his chamber. He began hauling them to the cabin, carrying 2 at a time in canvas slings. The work took 3 weeks. He needed enough stone to line all 4 walls and the floor of the chamber with a barrier 8 inches thick. The construction technique was critical. Alexander had no mortar, and even if he did, mortar would crack under the extreme temperature cycling the chamber would experience. Instead, he used a dry stack method, selecting each stone for how it fit against its neighbors. The floor went first. He laid the smoothest, flattest river rocks in a tight pattern, filling gaps with smaller stones until the entire chamber bottom was covered. No dirt showed through, just stone pressed against stone. The walls required different engineering. He started at the bottom and worked upward, choosing stones that locked together through shape rather than adhesive. Larger stones formed the structural layer. Smaller stones filled gaps. He worked with obsessive precision, rejecting stones that did not fit perfectly, searching through his collected pile for better options. Each wall took 5 days to complete. The stone barrier was not decorative. It was a battery, a thermal mass that would absorb heat energy and store it like water in a reservoir. Eleazar visited again in late June. He looked into the chamber, now lined completely with stone, and his mockery became uncertain. "That's fine stonework," he admitted, "but you've just built yourself a cold cellar with a hole in your floor. How's that supposed to heat anything?" Alexander was positioning capstones around the top edge of the chamber. "Fire at once," he said without looking up. "Stones heat to 500 degrees, stay hot for days, radiate through floor." Eleazar frowned. "Stone doesn't stay hot for days." Alexander set another capstone. "Then I've wasted the summer. We'll know by October." The stone chamber was complete by early July, but the most critical engineering remained. Alexander needed to create an opening that would allow wood loading and air intake while concentrating combustion into an intense, controlled burn. The opening also had to integrate with the cabin floor in a way that was both safe and functional. A hole in the floor large enough to fall through would be dangerous. A covering that blocked heat radiation would defeat the entire purpose. He began by studying the chamber's top edge. The stone walls rose to exactly floor level, creating a rectangular opening 4 feet by 6 feet. This was far too large. Alexander needed to reduce the actual firebox opening to approximately 18 inches across. He selected thick planks hewn from pine, each one 3 inches thick and carefully shaped. These would form a permanent frame around a much smaller central opening. The frame took 2 weeks to construct. He fitted planks around 3 sides of the chamber, leaving them removable for maintenance access, but heavy enough to support a person's weight. The planks rested directly on the stone capstones, distributing load to the chamber walls rather than spanning unsupported across the opening. On the 4th side, he created the furnace mouth itself, an 18-inch opening that dropped vertically into the stone-lined shaft below. The narrow opening was intentional and critical. Standard fireplaces had wide mouths because they relied on radiant heat from visible flames. Alexander's system worked differently. The narrow opening would create a chimney effect within the chamber itself. Air would be drawn in forcefully, creating a powerful updraft. Wood, stacked vertically in the shaft, would burn from top to bottom with intense heat, far hotter than wood burning in a conventional fireplace. The concentrated combustion would drive the stones to extreme temperatures. Around the furnace mouth, Alexander built a wooden grate system, removable plank sections that could be lifted out for loading wood into the chamber, fixed sections that provided structural support and prevented accidents. He drilled holes through the planks to allow heat to radiate upward while maintaining floor integrity. The pattern of holes was calculated, large enough for heat transfer, small enough that nothing could fall through. Eleazar arrived in early August and examined the completed floor system. He knelt beside the furnace mouth and peered down into the stone shaft. "I'll grant you this," he said slowly. "It's well built, but you'll never get a proper fire going in a hole that narrow and deep. Fire needs air. That shaft will choke it out." Alexander had anticipated this criticism. "Narrow opening creates draw," he explained. "Air pulls through fast. Hot fire. Complete burn." Eleazar remained skeptical. "And you're going to load wood down a hole 4 feet deep? That's awkward at best." Alexander demonstrated by lowering a split log into the chamber. The vertical orientation actually made loading easier than he had expected. Logs could be stood on end in the shaft, stacked efficiently. "We'll see," Eleazar said, standing up. "You've put 4 months into this. I hope for your sake it works, because winter won't care about effort." He left without further comment. Alexander returned to fitting the final floor planks. By mid-August, the floor was complete. The buried stove box was ready for testing. September arrived with cool nights that hinted at the winter to come. Alexander had spent the final weeks of summer preparing firewood, splitting logs into sizes that would fit vertically into the narrow furnace shaft. He cut each piece to 3 feet in length, allowing them to stand upright in the 4-foot chamber with space at the bottom for air circulation. The wood was seasoned pine and aspen, dried through the summer, ready to burn hot and clean. On September 12th, he decided to conduct the first test. The morning was cool enough to justify a fire, but not so cold that he desperately needed heat. This would be a controlled experiment, a chance to observe how the system performed without the pressure of survival depending on the outcome. He opened the removable floor sections around the furnace mouth and looked down into the stone-lined shaft. The chamber smelled of earth and stone. 4 months of work had led to this moment. He began loading wood. The first logs went to the bottom of the shaft, stood upright on the stone floor. He positioned them carefully, leaving gaps for air to flow between them. More logs followed, stacked vertically, creating a column of wood that rose 3 feet up from the chamber floor. He used smaller splits as kindling at the top, along with dry bark and pine needles. The loading process took 20 minutes. When finished, he had packed approximately 60 pounds of wood into the chamber. Alexander struck flint to steel, catching a spark in charred cloth. He transferred the ember to his kindling bundle and blew gently. Smoke rose, then flame. He lowered the burning bundle into the furnace mouth, placing it atop the stacked wood. The kindling caught immediately. Small flames spread across the top of the wood column. Then something remarkable happened. The narrow shaft created a powerful draw. Air rushed into the furnace mouth with audible force. The flames intensified, growing from tentative flickers to a roaring column of fire. The vertical stack of wood became a torch, burning with an intensity Alexander had never seen in a conventional fireplace. Heat radiated from the opening with shocking force. He stepped back instinctively, feeling his face flush from the thermal output. The fire burned with a sound like wind in a canyon. Flames filled the narrow shaft, contained by stone walls that began absorbing the enormous heat energy being released. Alexander replaced the removable floor planks, leaving only the 18-inch furnace mouth open. The floor around the opening grew warm within minutes. He moved around the cabin monitoring temperature, watching the system work. The existing chimney drew smoke efficiently. The stone walls contained the inferno below. Everything was functioning as designed. After 8 hours, the roaring intensity diminished. The flames settled to deep coals glowing in the chamber. By evening, even the coals had burned to ash. Alexander looked down into the shaft. No active fire remained, just spent ash on stone. He closed the furnace mouth with a metal plate he had fashioned for the purpose. Then he placed his hand on the floor planks. They were hot to the touch. The test had begun. Now he would discover if stone truly could store heat for days. The first morning after the firing, Alexander woke to a warm cabin. Not the localized heat of a fireplace that left your front hot and your back cold, but an even, gentle warmth rising from the floor itself. He walked barefoot across the planks. They were warm enough to be noticeably pleasant, but not uncomfortably hot. He opened the metal plate covering the furnace mouth and looked into the chamber. No fire burned, just cold ash resting on stone. But when he lowered his hand into the shaft, the stone walls radiated heat, like a summer rock face in afternoon sun. 3 days passed. The cabin remained warm. Alexander kept detailed notes on bark sheets, recording the temperature twice daily by his own sensation since he had no thermometer. Morning of day 4, still warm. Evening of day 4, still warm. He did not relight the fire. This was the test. How long could thermal mass sustain heat from a single firing? Every frontier trapper knew that fires went out, and cabins went cold. That was the fundamental reality of winter survival. But Alexander's cabin defied that reality. On day 7, he had visitors. Casper Lindholm, a Finnish trapper who worked territory 30 miles north, stopped while passing through on his way to a trading rendezvous. It was late afternoon. Casper entered the cabin and paused, confused. "You have a fire going?" he asked. Alexander shook his head. "Last fire was 7 days ago." Casper frowned. "That's not possible. This cabin is warm." He looked around for a hidden fireplace or stove, found nothing but the floor system with its central covered opening. Alexander lifted the metal plate. Casper peered into the furnace mouth, seeing the stone shaft descending into darkness. "What is this?" Alexander explained the system, while Casper listened with growing fascination. When the explanation finished, Casper knelt and put his hand on the floor planks. "Warm?" he confirmed. Then he reached into the shaft and touched the stone walls. "Very warm." "After 7 days?" Alexander nodded. Casper sat back, processing the implications. "This changes everything," he said quietly. "Do you understand what this means for winter survival?" Day 9 arrived, still warm. Day 12 brought Eleazar Godwin, drawn by stories Casper had spread at the rendezvous. Eleazar had mocked the project all summer. Now he entered the cabin in silence, felt the warm floor, examined the system, and said nothing for several minutes. Finally he spoke. "When did you last fire it?" 12 days ago." Eleazar checked the chamber himself, finding only cold ash. He straightened slowly. "I was wrong," he said simply. "I don't understand how this works, but I was wrong." Day 14. Day 15. The warmth persisted, gradually diminishing but still present, still keeping the cabin comfortable during cool September nights. On the morning of day 16, Alexander woke to a cabin that had finally cooled to match the outside temperature. The thermal mass had released its stored energy over more than 2 weeks. He had burned 60 pounds of wood once. A conventional fireplace would have consumed 10 times that amount over the same period, requiring constant attention, and still provided less consistent warmth. The impossible had become documented fact. The buried stove box worked precisely as designed. Winter arrived early in 1842. By late October, snow covered the high country. By November, temperatures dropped below zero and stayed there. Alexander fired his buried stove system every 2 weeks, each firing providing 16 to 18 days of warmth. His wood consumption was a fraction of what it had been the previous winter. Where he had burned through cords of wood, desperately trying to keep Joseph alive, he now used less than a quarter cord per month. The system worked flawlessly. Other trappers were not as fortunate. December brought the coldest temperatures anyone could remember, 30 below zero. For days at a stretch, men burned wood constantly, their fireplaces roaring day and night, consuming supplies at rates that threatened survival, cabins filled with smoke from overworked chimneys. The desperate heat of constant fires created dangerous conditions. On January 4, 1843, Lemuel Fairchild's cabin caught fire. Lemuel had been burning wood without pause for 3 days, trying to keep his small cabin warm enough to prevent frostbite during the brutal cold. The chimney stones, subjected to constant extreme heat, cracked. Sparks escaped through the crack into the wood structure surrounding the chimney. The dry logs caught. By the time Lemuel noticed flames spreading through his roof, the cabin was unsalvageable. He grabbed what supplies he could carry and fled into the night. The cabin burned to its foundation while he watched from 50 yards away, knowing that he now had no shelter in the deadliest part of winter. He reached Alexander's cabin 2 hours later, half frozen, carrying a pack of salvaged items. Alexander took him in without hesitation. The cabin was warm, despite no visible fire burning. Lemuel stood on the floor planks, feeling heat rise through his frozen boots, and nearly wept. "How is this warm?" he asked. Alexander showed him the system, explained the thermal mass principle, demonstrated by opening the furnace mouth to reveal the stone chamber below, still radiating heat from a firing 3 days earlier. Lemuel stayed through January and February. During that time, he watched Alexander fire the system 4 times total. Each firing took less than an hour of preparation and loading. Each provided over 2 weeks of consistent warmth. Meanwhile, other trappers Lemuel had known were burning wood every few hours, exhausting their supplies, risking chimney fires from overuse. The contrast was absolute. Alexander's system represented a fundamental improvement in survival technology. The coldest week came in late February, 7 consecutive days below 35 below zero. Trappers throughout the territory later reported that week as the worst conditions they had ever experienced. Several abandoned their cabins entirely, fleeing to lower elevations. 3 men died from exposure trying to reach settlements. Alexander fired his system once at the beginning of the week. He and Lemuel survived comfortably on that single firing, the thermal mass radiating stored heat, while the world outside became lethal. When spring finally arrived in March, Lemuel asked Alexander to help him build a new cabin with the same heating system. "I can't go back to conventional fires," Lemuel said, "not after seeing this. Will you teach me?" Alexander agreed. The technique would spread now, not through mockery, but through the undeniable proof of survival. Men who had laughed at the buried stove box were now asking how to build one. Spring of 1843 brought a quiet transformation across the northern territories. Lemuel Fairchild built his new cabin with Alexander's help, incorporating a buried stove system that took 6 weeks to complete. Word spread through the scattered trapping communities, not as dramatic news, but as practical information shared between men who valued survival over tradition. By summer, 3 more trappers had begun excavating chambers beneath their cabin floors. By the following winter, 7 cabins in Wyoming and Montana territories featured variations of the system. They were called different names in different places: Kowalski furnaces, underfloor stoves, buried fire boxes, the thermal pit. But the principle remained consistent across all variations: deep stone-lined chamber, narrow furnace opening, thermal mass that stored heat and released it slowly over weeks. The specific dimensions varied based on cabin size and builder skill, but the fundamental engineering was always the same. Men who had mocked the concept now studied it carefully, adapting it to their own circumstances. Emil Tolvanen, a Swedish trapper working the Bitterroot Range, built a system in 1844 after hearing descriptions from travelers. He modified the design slightly, using a circular chamber instead of rectangular, and achieved similar results. A single firing sustained his cabin for 14 days. He taught the technique to other Scandinavian trappers who recognized the principle from old-world heating traditions their grandparents had used. The knowledge spread organically, passed from builder to builder, refined through practical experience. Alexander never sought recognition or profit from the innovation. When trappers asked for guidance, he provided it freely. When traders suggested he could charge for consultation, he declined. The system had saved his life after Joseph's death. If it could save others, that was sufficient. He continued trapping through 1845, then left the mountains permanently. The fur trade was collapsing. Beaver populations had crashed. Silk had replaced felt in hat manufacturing, destroying the market that had driven the mountain man era. He traveled to Wisconsin Territory in 1846 and purchased land near a Polish settlement outside Milwaukee. He married Zofia Lewandowska in 1847. They built a small farm, raised 3 children, lived quietly. Alexander never spoke much about his years in the mountains. To his children, he was simply a farmer who had come west young and returned east to build a normal life. The buried stove system, the winter that killed Joseph, the months of excavation and mockery, these stories stayed private. Alexander died in October 1879 at age 62. His obituary in the Milwaukee newspaper noted that he had been a trapper in his youth and a farmer for 30 years. It mentioned his surviving wife and children. It made no reference to heating systems or engineering innovations. He was buried in the Catholic cemetery outside the city, his grave marked with a simple stone bearing his name and dates. But in the mountains he had left decades earlier, buried stove systems continued functioning in cabins scattered across the northern Rockies. Some were maintained by original builders. Others had been inherited by new occupants who recognized the superior construction and preserved it. The technique survived because it worked, because it solved a fundamental problem of frontier existence, and because men facing brutal winters chose engineering over tradition. The legacy was not in monuments or written records, but in warm cabins heated by stones buried beneath wooden floors, and in lives saved by knowledge shared freely across a harsh and unforgiving landscape.